Hi everyone. Today we are going to discuss about measuring instrument and the introduction about measuring instrument. So in last class we have seen the basics of electric circuits and voltage, what is voltage, current and etc. Today we are going to see the measuring instruments. So before going to see the measuring instruments, so first we can see what is measuring instrument. What is measuring instrument? Have you ever seen this meters? So in this meters, so why do we need these measuring instruments in electrical electronic instruments? Because these instruments used for all electrical measurements are called measuring instruments. They include ammeters, voltmeters, and energy meters. So without the help of these meters, we can't measure the electrical quantities. And before going to see what are the instruments and how it is works, first we can see the basic principles. So before going to see what is basic principles, we have three basic questions. The first question is, oh my God, how it is work? And second one is, how it is the pointer is moving. So this is the common question will arise between the students and those who studying this first. And third question is, how do instrument operates to measures electrical and electronic quantities? And here we have going to discuss about basic three torques. That is the main three torques. So first torque is deflecting torque. So have you ever seen this picture? And have you ever played with this magnet? Yes. So the electrostatic effect is used mainly for the deflecting torques makes the pointer moves from zero position to the final position. Yes. The next torque is the controlling torque. What is controlling torque? The controlling torques are used to keep the pointers of the instruments in one position and return back to its off position. Yes. Here we have an example. The pin. The pin, what we are doing is we are pulling the pin down and automatically come back to its rest position. Here we have two types of torque. One is a gravity control, next one is spindle control. Here the gravity control, what happens in this gravity control? So here the gravity control, we have a balanced load and we have a controlled weight. We have a balanced and controlled weight and angle of deflections of with the balanced and controlled, and we have pointers and we have spindles, etc. And in the spring torque, we have balanced springs. We have with the help of spring, we can control the spring control. Okay. Here we have next torque is damping torque. What is damping torque? It is used to reduce the oscillations of the pointer and also reaches the rest position of the pointer. So it reduces the oscillations. Here we have two types of damping. One is air damping. In this air damping, we have spindle, boxes, and metal values, etc. And next example is eddy current damping. In eddy current damping, we have same the spindle and we have a disc and we have a pointers and we have a dynamic magnet. Okay. So now next we are moving to what are the type of instruments we have. So basically we have three types of instrument. One is moving ion instrument, one is a moving coil instrument, and next one is dynamometer type instruments. In moving ion instruments, we have attraction and repulsion type AC and DC ammeters and attraction repulsion type AC and DC voltmeters. In moving coil, we have permanent magnet type DC ammeters and permanent magnet type DC voltmeters. And dynamometer type, we have ammeter, voltmeters, and wattmeters. Okay. Here we have next. We have a question. We have two types of supplies. We have an AC supply and DC supply. Can I use the same instrument for measuring the two supply? Yes, we can measure the both AC supply and DC supply in the same instruments. How it is possible? Here we can see. So in this moving coil instrument, we have two types. One is permanent magnet. Next one is dynamometer type. In permanent magnet type, we can measure only DC supply. In electromagnet type, we can measures both AC and DC supplies. Okay. Now, before going to the permanent magnet moving coil instruments, first we can see the basic principles of permanent magnet type. So what principle it works? So when a current carrying conductor placed in a magnetic field, it is acted upon by the force which tends to move it one side and out of the field. Here the permanent magnet, when a current carrying coil is placed in a magnetic field, it is acted upon by the force which tends to move it from one side to another side. Okay. Here deflecting torque. Here comes to the deflecting torque. Here the deflecting torque is nothing but force. Here the force is applied. This is known as deflecting torque. We know that the force formula is BIL, is Newton. So B stands for flux density and I stands for L stands for length or the depth of the coils. And the deflecting torque is the force into perpendicular distance. And N force, the force formula is NBIL into B, that is NBI L into B, NBIA, that is measured in Newton meter. Here the finally the controlling torque is equal to deflecting torque, hence C theta is equal to K and to I. Here we can see the what are the components. We have pointers, moving coils, and the magnet, permanent magnet, and spindle, and we have dialer, and we have a mirror. So these are the components, basic components we have in permanent magnet moving coil instruments. Okay, we can see the animation video of permanent magnet moving coil instruments.
आज का वीडियो बताओ ये परमानेंट मैग्नेट कॉइल इंस्ट्रूमेंट तो आज तो कैसे करते देखते हैं इसके अंदर
Here we can see
जानेंगे
basic.
इसका वर्किंग समझ जाए यहाँ पर जो मेन जो चीजें आपको यहाँ पर
We have north pole, south pole, and we have a spindle, we have a spindle, we have a spring, and we are having a bearings, and we have a pointers, and we have an aluminum foil, and we have an coil, and we have a connecting leads, and with this lead we are going with the electrical supply, and actually the flows, how the force. Here, here when the coil, when the giving supply to the coil, what happens? The coil, how the current flows in the coil. You can see the how the current flows in the coil. Okay. How the coil is mounted. So now here we have the magnetic field. Here the magnetic flux. When we are giving supply, what happens? When the current carrying conductors touch the magnetic field, then a force is produced, and with the force, the pointer is moved. We can see the working animation of permanent magnet moving coil.
यहाँ पर जो पॉइंटर है इस पॉइंटर के ऊपर फोर्स कम लगेगा मतलब टॉर्क कम लगेगा ठीक है अब ये
torque is
फॉर्मूला है जो
produced.
टॉर्क का जो फॉर्मूला है या फिर
We have a torque is produced.
टॉर्क का जो फॉर्मूला है ये डिफ्लेक्टिंग
First we know have seen the deflecting torque,
फॉर्मूला है वो होता है NBLI
and we know the formula. See how the deflecting torque is applied.
जब हम सप्लाई देंगे तभी ये डिफ्लेक्टिंग टॉर्क प्रोड्यूस ध्यान से समझना जब कॉइल
How the coil is working.
कंट्रोलिंग टॉर्क क्या करता है
So controlling torque pointer.
रेस्ट पोजीशन में या फिर जीरो
So
पोजीशन
it's from zero position and it moves. So controlling torque with the help of magnetic balanced magnet.
टॉर्क ज्यादा होगा अब जैसे ये डिफ्लेक्टिंग टॉर्क पॉइंटर है ये पॉइंटर एक्यूरेट
So pointer moves. Here we can see the animations.
एल्युमिनियम फॉर्मर को यहाँ पर रखना बहुत जरूरी है ये एल्युमिनियम
So we can see the animation.
होता है ना तो क्या होता है यहाँ पर जो मैग्नेटिक जो फ्लक्स होता है इस फ्लक्स को कट करता है इसके अंदर से
So eddy current. Here the eddy current losses how?
ऊपर भी एक टॉर्क लगेगा जो टॉर्क क्या करता है आज का वीडियो का टॉपिक परमानेंट
Okay, we have seen the animation video of permanent magnet moving coil instruments. And finally, we are moving to the advantages or disadvantages of permanent magnet moving coil instrument. Here we are the first advantages is it's a low power consumption. And second, the scales are uniforms. and third one is there is no hysteresis losses. These are the main three advantages of permanent magnet moving coil. So comes to the disadvantages, what it is somewhat costlier compared to the moving ion instrument, and it can't be used for AC measurement because we have seen the electrodynamic type instrument is only used for both AC and DC supply measurements. And finally, the friction and temperature might introduce error as in case of other instruments. Okay, these are all the advantages and disadvantages of permanent magnet moving coil instruments. Okay, thank you. So in this next video, we can see some other instruments. Thank you so much.